Thank you. Welcome, everyone. I hope you're enjoying the conference so far. We've seen a number of really great talks, and hopefully you enjoyed this one. A token walks into a spa, and just a fair warning, this has nothing to do with massages or hot water or anything like that. We're going to be talking about single-page application security, so if that's not what you're into, feel free to leave right now, and I won't get mad. So let's get started. A bit about me. My name is Kukic, and I work as a developer evangelist for a company called Auth0. And Auth0 is an identity management company that provides a universal authentication and authorization platform for web, mobile, IoT, and legacy applications. And you can find me at Kukic if you have any questions. We'll have some time at the end, though, so don't worry. So let's get into it. Single-page application security best practices. And when I talk about single-page apps, I talk about Angular, React, Vue. We could talk about Backbone. Okay, looks like we're back. So we're talking about single-page application security best practices, and that can be Angular, React, Vue, Backbone, Knockout. I don't think Backbone, but Knockout, or your own JavaScript-based framework that you've written. And so what are the single-page application security best practices? These applications, they typically live entirely in the browser. So when a user visits your site, the entire application gets loaded into the browser, and when they navigate routes, when they access data, all of that is already alive in the browser, so they get really good load times. They get almost instantaneous load times, page refreshes, and all that stuff. But how do we secure these applications and make sure that the data is secure? Well, we really can't, right? Because all of the code, all of our Angular, all of our React code lives entirely in the browser. So we can't really have secure or private data that lives within these applications without exposing it to a malicious party that could, with enough effort, easily figure out what data you're trying to obfuscate and hide. So what can we do about it? We all love building single-page apps, so how do we make sure that our data is secure? That's really what this talk is about today. But first, let's take a look at how we've traditionally built applications and why they're secure the way that they are. Typically, we had our production environment, our application environment that was fully secure, that lives behind a firewall that we fully control, and nobody, it's kind of like a black box, nobody can see inside of it. And then we have the browser where the user interacts with our applications. So we have our application server, our application, and in this case, we're going to be using Avengers.com as our demo going forward. And then we have our user coming to our application. So when they land on Avengers.com, the browser makes a request to the backend server and says, hey, can you send me the home page? And the server is going to look at this request, see that it doesn't need to be protected, that it's a fairly public request, and it's going to render the page, all of the HTML, all of the styles on the server, and then serve it back to the user, and the browser is just going to display that pre-rendered HTML, CSS, images, and so on and so forth. And when it comes time to access a protected resource in a traditional web application, the way it works is we have our application, we have our server, and once the server is authenticated, they have a session cookie in their browser. And this is just a arbitrary string of characters that is passed along with every single request. So when a user makes a request to the backend, to like the account page or a shop page or whatever protected resource, we take a look at that cookie on the server, send that to our session database, and if it's still an active session, if it's still valid, we go ahead, render that request, render the HTML, the CSS images, and send it back to the user. And the user's happy, our application's secure, we don't have any issues. But that's kind of the traditional way of building web applications without Angular or React or these SPA frameworks. The way we typically build quote-unquote modern applications is we have this kind of shrunk down production secure environment, and a lot of our logic is actually offloaded to the browser thanks to these applications. So now, instead of building all of our logic, all of our UIs, HTML, CSS, data access onto a single server, we might just expose an API. So say api.avengers.com that sends and receives JSON responses based on what the request is. And then we have our application at app.avengers.com. And again, it can be React, it can be Angular, it could be a custom framework. And it handles the presentation layer. It handles how the user makes the request, what they can do, the routing, and all of that fun stuff. So also being the modern developers that we are, and since we have this API, we might also be thinking of, not only having a web application, we might be thinking of, developing a mobile application down the line, a IoT device such as a Google Home or like an Echo device. And wouldn't it be great if all of these, client, dumb applications could just talk to a single backend server, make requests, make a post request, send some JSON data, and get some JSON data back. And that's, typically kind of what we want and the way that modern applications are built. But how do we secure these applications in a way that works across all three of these mediums with the least amount of friction? Because remember, since these applications are client-side, they're public, we can't have private data in them, and our API server is locked down, it's secure. So the way that we're going to be able to access secure data and private data is we're going to lock down our transportation layer, these two little arrows. We're going to have a methodology in there that's going to help us make secure requests. And the way we're going to do that is via JSON Web Tokens. Now, how many of you guys have worked with JSON Web Tokens before? OK, about half of you. Perfect. For those of you guys that haven't, JSON Web Tokens are an open industry standard method for representing claims securely between two parties. Now, that's its definition, but that might not be the best definition. So let's take a look at what a JSON Web Token looks like, and I'm sure it'll clear up any confusion that you might have. Yeah, it's they're not very user-friendly, but we'll get into what JSON Web Tokens are and how they work in a little bit. But this is basically a JSON Web Token. This is what we're going to send to our backend server from our single-page application that's going to help us validate that request and ensure that it is a valid request that we can fulfill. So when I first started learning about JSON Web Tokens and web security and how to do it properly, I kind of did the technical route, reading the RFC spec, kind of trying to look at the different libraries that implement it. And I was, for a long time, I was confused as how it worked, why it worked. So what I want to do in this presentation is kind of look at it from a real-world perspective. And that's kind of where that token walks into a spa title came from. We're going to use token-based authentication in the real world to show a user, how a user orders a beer, and then kind of tie it back to technology. So we're going to look at a driver's license as a JSON Web Token or as a method of token-based authentication, see how it's used in the real world, and then tie it back into how we would use it in our single-page applications. So what I'm going to answer over the next couple of minutes is, how is a driver's license like a JSON Web Token? So a JSON Web Token is comprised of 3 different parts. So let's take these 3 different parts and kind of tie them back into the driver's license example and also the JSON Web Token to kind of see if the analogy works. So the first part is the header. And we'll put our driver's license and our JSON Web Token side by side. Now, the header of a JSON Web Token, or a token, is basically just tells you what you're looking at. So if we take a look at our driver's license example, the header might be the fact that it's a driver's license. It says so on it, and that this particular driver's license was issued by the state of New York. So just kind of general data that every driver's license would have. If we look at our header, the header is this first part in green starting with EYJ and then ending in CJ9. So that's our header. And for any of you guys that have worked with base64 encoding before, this is a base64 URL encoded string that if we were to decode, we would get a JSON object that has these following properties. So it has an ALG property that stands for algorithm, and in this case, it's HS256, and we don't have to worry about that for now. And then the second property we have is TYP, which stands for type, and here it's a JSON Web Token. And as long as you're working with JSON Web Tokens, the type will always be JSON Web Token. So the header, not too much interesting information there. The real meat of the JSON Web Token comes from the payload. And let's put our driver's license and our token side by side again, and look at the payload. Now the payload is this part in blue for the token, and for our driver's license, the payload is all of the information contained within the driver's license. So information such as the user's picture, their name, their address, their demographics, and also most importantly, their restrictions. So what type of motor vehicles can they operate, how long it's valid, so on and so forth. Now, if we look at the payload, the blue part of the JSON Web Token, it too is a base64 URL encoded string that if we were to decode, we would get another JSON object back that has a couple of different properties. So it has a SUB property that stands for subject, which is essentially the user ID or their identifier. We have the user's given name, their family name, this admin property that's set to true. So here we can put any sort of valid JSON data we want. So any claim that we want to represent, we can, although the JWT spec does have a couple of different guidelines or parameters. So they have what are referred to as reserved claims, and the SUB claim, for example, the subject claim is a reserved claim. And there's only a small number of these that you should include with every JSON Web Token. So like the subject, the EXP claim, which stands for expiration, the IAT claim, which stands for issued at, so you know when the token was issued, the ISS claim, which is the issuer, so who generated this token, so on and so forth. And then we have what are referred to as public claims. And examples of public claims are these given name and family name. So these are claims registered by the OpenID Foundation. And these really help with API interoperability. So if you're building an identity management platform, for example, that's going to talk to many different APIs, you'd kind of want a standardized way of representing user information across different APIs. So instead of saying, like first name, you might do this kind of, internationally standard given name or family name for the surname or the last name. And then the last part of the payload, the last type of claim you can make is what's referred to as a private claim. And our example here is this admin property set to true. And these claims are only specific to your application domain. They're only specific to your application. So you can basically put whatever you want here. So instead of admin true, you could put, ability to delete users, 1 or 0 or a string, or pass in an array of different permissions that the user can take. You can represent this, to fit your needs. But that's the payload, and that's basically going to tell you what your application, what you can do with the specific JSON Web Token. Now, the last part of the JSON Web Token is its signature. And this is kind of where we get the validity and the kind of trust for the token. So if we look at our driver's license and token side by side again, the signature of the driver's license is typically a UV light hologram that's kind of embedded on the driver's license that kind of proves that it came from a government agency, or there might be a barcode on there, or like a QR code that'll help the proper authorities validate that this token did come from them and wasn't faked. Now, when we look at the signature of our JSON Web Token, that's this last part in black, starting with UL and then ending in FGI. And this is not a base64 URL encoded string. This is just a cryptographic hash that was generated by taking the base64 URL encoded header, the base64 URL encoded payload, and then running it through a hashing algorithm with a password. So in the case of the HMAC SHA-256 algorithm, you just use a string-based password. So in this example, we use Loki sucks, but it could have been anything, and it should. And you probably wouldn't want to use such a short string. You probably want it to be 64 more bytes. But that's how you would kind of sign this header and payload, send it to the browser, and then anytime the user makes a request, they send this token with them. You verify it against that particular password, and if it passes, then you know that the token is still valid. Now, HMAC SHA-256 is very easy to demonstrate, so that's why I'm showing it here, but because it just does use that string-based password. But RS-256, for example, uses a private-public key pair, which is much more secure and offers much greater security and flexibility. So that's what you should be using if you're working with JSON Web Tokens. But I kind of didn't want to paste a whole private key. It'd be kind of crappy to read. So we're just going to stick to HMAC for our examples here. So let's see how we would use token-based authentication in the real world. The Avengers just wrapped shooting the reshoots for their new movie, and Thor wants to go to the bar and order a drink. And he doesn't have a valid driver's license, even though he's over the age of 18. So what he first needs to do is go to a trusted government agency like a Department of Motor Vehicles or whatever it's called in Croatia, submit a whole bunch of paperwork, wait a whole bunch of time, and they'll get him in the system, they'll get him verified, and they'll issue him a driver's license. So now he has his token, he has his driver's license, and now he can go to the bar. When he gets to the bar, orders a drink, the bartender asks him, I need to see your ID first, and since he does have it, he'll present it, and she might run it through a UV hologram or just look at it, and if it's all good, he gets the thumbs up, and he can order a drink. If he goes to a different bar, he needs to do the same thing. He has to show his driver's license. It needs to be validated. If it's still valid, he can order a drink. But knowing Thor, I don't know him personally, but I would just assume that he wouldn't be the type of person that would want to wait 4 to 6 hours for a driver's license. So he might go to a shady character, give him some money and say, hey, can you create me a fake ID so that I can, go to the bar sooner? And this guy's like, yeah, I'll take your money. I'll give you this legitimate-looking driver's license. It has the header. It has the payload. It has some type of signature on it. But now, when Thor goes to the bar and tries to order a drink, he presents his token. He presents his driver's license. And the security guard out front or the bartender looks at it, runs it through a system, and notices that there's falsified data, the signature doesn't match, something doesn't add up, so Thor is unable to get his drink. And that's how token-based authentication works in the real world. Now let's kind of see how it works with our single-page applications. So again, we have our server and we have our SPA application. Again, it could be Angular, it could be React, it could be whatever framework you're using. We're going to be framework agnostic. And say the user wants to, alert the Avengers of something going on, so they hit the SOS endpoint, say, help somebody, somebody needs help. And the Avengers, they set up token-based authentication with JSON Web Tokens on their server. And this request came in, it didn't have a valid token, we don't know who the user is. So what this server is going to do is it's going to respond back with a 401 or a 403, depending on how you issue HTTP warnings or errors. And it's going to say, hey, you're not authorized to talk to this endpoint. You need to be authenticated first. So what the user is going to do now is they're going to hit the authentication endpoint. They're going to provide their username and password credentials, or they might go and log in with Facebook, log in with Google, do an OAuth type login or single sign-on. It doesn't matter how they authenticate. But once they're authenticated, the server is going to respond successfully. So it's going to respond with a status 200, and it's going to send back a JSON Web Token that's going to have that signature, that's going to have that header, payload, and signature. And now our single-page application is going to store this token. And now when we go to make a request to that SOS endpoint, we're going to pass along our JSON Web Token. And typically, what you want to do is pass this token along in an authorization header in the format of bearer, since it's a bearer token, and the token itself. Now, you could also additionally, pass this as a query string parameter or as a, within the data section of a post request, but doing it via an authorization header is probably the best way to do it. Now, when we send this authorization, or when we send this request with this JSON Web Token, our authorization server, first it's going to say, hey, okay, I got this request, it's come in. Does it have an authorization header? Yes, it does. Then it's going to say, let me extract a token out of it. It's going to check the token validity. So it's going to say, is this a valid JSON Web Token? And if it is, it's going to say, great. Now let me see if this token's expired. And if the token's not expired, it's going to say, OK, great. Now let me check if this token has the right permissions to fulfill this action. And if it does, it's going to send back a successful message. It's going to say, OK, we got your message, status 200, we assigned the Hulk to it. If at any point, though, if there was no token, if the token was expired, if it didn't have the permissions, then the request would short circuit and you would send back the appropriate message. So you could say, you don't have the permission to do this, or your token's expires, please re-authenticate, so on and so forth. Now let's see how this would actually look in code. So here I'm using the excellent Axios HTTP request library that you can use with basically any modern framework. So for making a post request, we get our API URL, we tell it which endpoint to call, and we're attaching the authorization header here. So let's see if this works. There we go. So we're attaching a header of type authorization, setting it to bearer, and then the JSON Web Token. It's going to get sent, and then in the callback, we're going to get the data back and get that same message. Now what happens on our backend, on our server, say we have these two routes. One is public and one is protected. So we have this API public route that just processes the request and sends back whatever message we want. For the protected route, we added a Node.js middleware, an Express middleware called check JSON Web Token, which is going to be charged with verifying and validating this token before it goes and processes this message. And if we look at the middleware, the check JWT middleware, we have our request response next. So the first thing we're going to do is validate and verify that the token is valid and that it was signed with the password Loki sucks. And if that's good, we're going to check the claims. And if the user is an admin in this example, since we're trying to access the admin route, we're going to say, OK, go ahead next, process that, send the message that you need to send. But if the claims don't come back successful because we couldn't verify the token, then we're going to just respond back, short circuit the request, and send back an unauthorized message or some type of error. So that's a little bit of a code example on how it works. Now let's take a look at a bit more of a complex example of JSON Web Token authentication in the wild. So now we have our authorization, we have our application server, we have our single page application, and now we have our authorization server. So this is a typical OAuth 2 scenario where you authenticate users at a separate domain than your application for increased security, flexibility, so on and so forth. So you have api.avengers.com, you have app.avengers.com, and now you have your authentication server, say login.avengers.com. What's going to happen in this scenario is when the user lands at your single page application, right here, they're going to click the login button, and they're going to be redirected to login.avengers.com, where they're going to present their authentication credentials. So here they're going to log in however they log in, username, password, passwordless, single sign-on, whatever. They're going to log in, validate their credentials, and once they're successfully logged in, the authorization server is going to make a callback request back to your single page application with this JSON Web Token. And since there's no emoji for JSON Web Token, I just used this Japanese emoji that stands for open for business. So you'll see that throughout the rest of the talk, so just fun fact. So now our single page application has a token, but our api.avengers.com isn't concerned with it. It doesn't even know or care that this transaction happened. It only starts caring when our single page application goes to make a request to the API. And when we make a request, we attach that JSON Web Token with the request. The server is then going to say, hey, I have this JSON Web Token. Let me verify. Let me make sure it has all the right payloads. It's not expired, so on and so forth. And only then is it going to send back a successful response. Now, at this point, a typical question that I get is, where do I store this JSON Web Token when the authorization server sends it to me? Do I store it in a cookie? Do I store it in like local storage or session storage? Now, where do I store it so that I can continue to use this application without having the user log in every single time they refresh the page or open it up in a new tab? And the best practice these days is to not store the token anywhere. And the reason for that is if you've looked at any of the there was an earlier session today on web app security. If you're susceptible to a cross-site scripting attack or cross-site request forgery, if somebody is able to steal this JSON Web Token from your single page application, then they can basically imitate your user, impersonate your user, and do all sorts of bad stuff with it. So if you were to store your token in a cookie or or local storage, you just kind of opened up an attack vector for a bad guy to misuse and hack your application. So let's kind of take a look at how we would mitigate this. So we have our API.Avengers, we have our app.Avengers, and we have our login server. Our user is going to, again, go to the login server, authorization server to authenticate. Once they're authenticated, what we're going to do is we're going to set a session identifier, a session cookie, only on the authorization server saying, hey, this user's logged in, and then we're going to issue that callback with the JSON Web Token for our single page application. At this point, our single page application is going to take the token that it receives, the Axios token, and it's going to store it in memory. So it might be, if you're using React, you might store it in a Redux store, or if you're using Vue, it might be like a Vuex store. You're just going to store it locally in memory so that when the page is refreshed, that token gets destroyed. And then you can make those requests and responses, go back and forth. But at this point, if we were to do this, we have this session cookie on the authorization server. Our single page app really has nothing to do with the authorization server other than sending the user back and forth. So at this point, if you were to refresh that single page application, the user would still be logged out because that in-memory Axios token, that JSON Web Token, would be destroyed. So how do we get around that without giving the users a really crappy experience where they have to log in every single time the page is refreshed? The answer to that is what we refer to, or you might have heard, silent authentication or token renewal. And the way that this works is, in this scenario, we just refresh the page. So we have this session cookie on the authorization server. What we're going to do is we're going to make a silent authentication request from our single page app to the authorization server. And this is typically done in an iframe in your single page application. So you open up an iframe, you say, go to the authorization server, see if this user's logged in, see if they should have an Axios token. And when that request is made, your authorization server is going to basically run a traditional web app request, check that session ID, see if it's still valid, and then it's going to issue a new JSON Web Token and send it back to your application. Now, it's not going to do this via a callback. It's going to do this in that iframe that you generated. So then you can use the post data APIs to basically push that JSON Web Token that you received in the iframe up to your single page application where your Spa can consume it and then use it, sending it back and forth to your application. Now, I know that was kind of a really complex way of doing it, so I'll save some extra time for questions. But that's basically how token-based authentication works with single-page applications. So here, let's talk about some additional resources for single-page for JSON Web Tokens if you're interested. General JWT resources can be found at jwt.io. And this is a website that's partly maintained by Auth0. And here you can find different libraries for, that implement JSON Web Tokens for all sorts of different languages. So whether you're working with Express or Go, Java, ASP.NET, there's libraries, some that we contribute to, some that we maintain, and then others that are community managed. Overview of JSON Web Token signing algorithms can be found at this bit.ly link, jwt-alg. So here, we talk about the HMAC and the HS and the RS-256 signing algorithms, how they work, why they work, and best practices for when to use one over the other and why one is more secure than the other. And then if you really want to get into all the nitty-gritty things about JSON Web Tokens, one of my colleagues at Auth0 has written a free handbook called the JWT Handbook. And here you can learn more about JSON Web Tokens than anyone should ever know. But if you're interested, that's a pretty good resource. And one thing I did forget to mention when we were talking about, I'm just going to zoom way back here, because I think this is very important and probably the most important part. Let's keep going. Here in the payload is that even though you can put any sort of JSON data within the payload, you shouldn't put any sensitive data, such as credit card numbers, personally identifiable information, such as user addresses or driver's license numbers, for example. Any data that the browser, that the single-page application shouldn't have access to, you also shouldn't put in the JSON Web Token either. Otherwise, if the token is compromised, if it does leak, then anybody can easily decode the token and see what's held within it. They just can't use it or can't modify it and use it against your application. With that said, a brief summary. So, single-page application security is mainly concerned with authorization. Since we can't have private data, since we can't have secure data within our SPAs, we were mainly concerned with the access to secured backend servers. JSON Web Tokens are excellent for securing single-page applications, and this isn't a cookies or sessions are better than JSON Web Tokens. They both have their pros and cons. JSON Web Tokens just happen to be really flexible and really powerful when it comes to SPAs as well as mobile applications. And then there are many excellent JWT libraries for all languages and frameworks. So it doesn't matter what type of developer you are, what language, what framework you're using. There's likely a JSON Web Token library already built, already validated with the community that works and will get the job done. And as far as working with JSON Web Tokens in the browser, I showed Axios, but you can use XML HTTP requests, you could use the Fetch API, you can use Angular's HTTP library very easily to modify headers and work with those. And then finally, a security guard probably couldn't stop Thor, but your server can refuse requests without valid JSON Web Tokens very easily and very securely and every single time. To close out, I do want to mention that Auth0 is taking part in Hacktoberfest this month. So during the month of October, from the 1st to the 31st, we are basically sponsoring Hacktoberfest, which is for new developers who are just starting to get into development and are interested in contributing their first PR, contributing to open source. Auth0, we made many of our 700 plus libraries available to open source for individuals to contribute to, make edits, make changes, make requests. And if you make, I believe, 4 or 5 PRs within this month, you get this really cool swag that includes an exclusive Hacktoberfest t-shirt and some stickers, and everybody loves stickers. And with that, thank you guys so much. I think we have some time for questions, so I'll open it up.
Awesome job, Otto. Thank you. We do have time for questions. I see a hand, several hands, and try to get as many people as possible.
Hi.
Hey.
First of all, great presentation. Thanks a lot. I have a question. So we don't store the token in the browser so it doesn't get hijacked, right? But we store some cookies so we can refresh that token later. What if somebody steals the cookies? Can't they refresh the token instead of us then?
Yeah. Okay, so if I understand the question right, was so we don't store the token in local storage or session storage, but we do have that cookie stored somewhere. So what happens if a malicious person tries to steal that cookie? And that's a very good question. And The reason that we can store the session identifier in a cookie is we would store it in a secured cookie, which basically wouldn't give JavaScript any access to that cookie. So it wouldn't be able to access the cookie itself. That cookie would just be sent with the request to the authorization server to issue and generate a new JSON Web Token. So if you were susceptible to a cross-site scripting attack, for example, the script wouldn't be able to go into cookie storage and take that cookie. Mm-hmm.
Hello. There are two major drawbacks, let's say like that, like size, because session is like, let's say, under 10 bytes, and the JWT is around 300 approximately. It can be bigger, of course, depends on what you store in that, but size matters, because every request must send that JWT. Mm-hmm. And second problem, session invalidation. How can you invalidate a JWT token that's on the client side? Because there is no way to tell all of my clients to invalidate their tokens. For example, I have a rogue attack on my account. Somebody has my password. I change my password, but I cannot invalidate valid sessions. And the second problem is, let's say my main key is compromised. And how can I tell all my clients to invalidate their tokens?
Okay,
That's
perfect. So we have three questions there. So the first one was cookie versus JSON Web Token size. So a session might be 4, 5, 10 bytes, depending on how long it is. A JSON Web Token is going to be at a minimum 4 or 5 kilobytes. And then depending on how much data you put in there, it might be hundreds, 100, 200, 300 kilobytes. And it's sent with every single request because it needs to be validated every single time. This could be a problem if you're developing applications that have very limited bandwidth, that are where latency is important. But we did some tests where if you're looking at a million requests over a month, or like 20 million requests, that if you're using JSON Web Tokens over session, over just traditional cookie sessions, the amount of data you're sending over the wire, over a month period is only like 20, 30 megabytes more. So it's not, it's no longer such a big problem with the size. It's only a couple hundred bytes here and there that it is a valid concern. But at the, when you look at the picture, at the big picture, it's not as big of an issue. Now, the second question was validating the tokens client side, so in the browser. You typically wouldn't ever need to validate the tokens client side, because you would have to expose that secret to the client, to the browser. And if you expose your secret to the browser, then you have the problem of, now the bad guys know your secret. They can generate new tokens off of that and do all sorts of bad things. But the third question regarding what if your key is compromised? So what if somebody, figures out that your keys, your JSON Web Tokens are signed with, Loki sucks. In that case, what you would do is you would change your signing key, so change it to a different password. And what that would do is it would invalidate all of the issue JSON Web Tokens that are in the wild. So, if you had 100,000 users logged in and you change the signing key, then all 100,000 of those users would automatically be logged out. Those keys would be useless. They would have to re-authenticate to get a new key. And then there is a valid concern there in token, how do you validate that a token, I think you kind of brushed up on it. What if you change your password, or what if you start a new job, you log in, and you get fired, and you're still logged in? You can't destroy that JSON Web Token in a user's browser. What do you do there? And the answer to that question really is you can maintain a token blacklist. So when you verify the claims of the token, in your JWT check middleware, or wherever you do it, you can run it against the database and say, hey, should this user still be logged in? Should this user have access? So, it's no longer a stateless system, but it is sometimes required to be able to validate that, some tokens shouldn't still be valid even though they exist out in the wild. Does that kind of answer your question? Sure. Yeah. So one potentially useful thing that you would gain, if you were comparing JSON Web Tokens to traditional sessions, is you can store any types of claims in the token. So instead of getting a session identifier, checking it against the database and seeing if it's still valid, and then making another database call to see, if the user should have permissions or, who the user is. You can do all of that in a JSON Web Token. So you just do one database check to see if it's a valid token, and then you have all their permissions, all their actions. So that could kind of simplify your code base a little bit. The other big benefit is if you're working with cross-domain. So if you have like an API.avengers.com and an app, or if you have different third-party applications, then using JSON Web Tokens is much easier than kind of trying to deal with cross-domain cookies, which almost never works.
Thank you.
Thank you. So the question is regarding silent login. You said to store nothing on the client, right?
Sorry, what was the question?
So you said not to store anything on the client side.
Right.
Yeah. Mm-hmm. So you logged in, you're on some protected page already, and you hit refresh. Mm-hmm. What do you send during this silent login? I mean, how do you know when the page is refreshed and reloaded? What are you sending then?
Sure. So what happens there is, I'm just going to zoom through this really quick. So what happens in this instance where actually, let's get rid of these guys. So, let's say you logged in, you had your token, but now you hit refresh, or you opened up the page in a new tab. What happens is your single page application now, it doesn't have a JSON Web Token because it was in memory. Now it's gone, so you're no longer logged in. So what you do is you have a bit of code in your single page application that creates an iframe in your single page application and goes to the authorization server, makes a request, just like a request to the authorization server. It might be like an endpoint that says, verify user, like check user. And this request gets processed on the authorization server now. You have this cookie here, and this server on this third-party server, basically. It could be your own server. It could be like Auth0, for example. But you're going to have an authentication cookie, a session cookie, on a different domain that's going to validate the user. The cookie would exist in that iframe. It would be a secure cookie that's talking on a totally different domain that would verify that the user is logged in. And if they are logged in, if that session cookie is good, then we would issue a new JSON Web Token back to the single page application. So you can have, you could generate as many of these access tokens, JSON Web Tokens, as you want, and destroy them. They'll expire on their own in 10, 20, however many minutes you set it to.
More questions? Anyone? All right. Well, if you have any more, I'm sure you can find Otto around the conference and outside. Let's have another big hand for his talk.
Awesome. Thank you, guys.